All right, and last video for this week. Hopefully, again, you've watched the first two videos. I think those were the most important parts of this week, especially the second video. There was a lot of information packed into that. Not too hard of a concept, hopefully, but you got to make sure that you understand that. It's especially going to be very useful when we jump into some more in depth into next week. So make sure you watch those. If you're ready to move on and you feel comfortable with those two concepts, we can jump into our last video for this week. So let's go ahead and open up these notes and dive right into this. So we have looked at these first two standards here. So determining the measures of angles in arcs in circles. That was video number 1. So we're good there. Determine the relationship between central angles, inscribed angles, and intercepted arcs. Okay, hopefully you watched last video, you understand the central angle is equal to the measure of that arc, and the inscribed angle that's equal to half of that intercepted arc. So hopefully we've got that down as well. Now in this video, we are going to look at this last standard, determine the relationship between our arcs and our chords. Now, I mentioned that vocab word last week, or not last week, in the last video, and I just briefly talked about it, but let's go ahead and dive into what is a chord. So a chord, it's just a segment with endpoints on your circle. So I have a couple examples here. Now, we have actually talked about a specific type of chord. That is our diameter. So from C to D, it connects 2 points on your circle. Okay. Now, what's special about it is it goes through the center. So a diameter, and we can actually make a quick note about this if you want to. A diameter is the longest chord. If you think about any other chord outside of a diameter, so if I take a point from C and I connect it with D here, okay, if I go anywhere along the circle, that chord is going to get shorter and shorter until I end up back at C. Same thing here. If I go the opposite way, it's going to get shorter and shorter. So your diameter, that is your longest chord. It's a very special chord. But we have other chords, infinitely many other chords. In this example, we have A, B, we have E, F. They're just segments. Okay. So now, what can we do with those chords? Well, we have 4 chords theorems that we're going to talk about. Okay, some of them might seem like kind of well-duh theorems. Some of them might seem a little more in-depth, a little more complicated. So this first one, if 2 chords are congruent, then their corresponding arcs are congruent, and vice versa. So what that tells us here is, if I look at this picture, okay, if I know FG and JH are congruent to each other, well, the arcs, their corresponding arcs, so in this case, arc FG and arc JH, those are going to be congruent to each other as well. So they're going to have the same measure. They're going to have the same length. Okay, and it works both ways. So if I know those 2 arcs are congruent, so if they are both, let's say, 80 degrees, well, then I know FG and JH, those 2 chords, are congruent. Again, I think that one is kind of a well-duh theorem. But you could always play around. If you take FG and you try to move it around, you're always going to get the same chord, or the same length of arc, same measure of arc. All right. Second theorem, this one's a little more complicated. If a diameter, or a radius in that case, is perpendicular to a chord, then it bisects that chord and the arc. Okay, so if I look at this picture here, so I have a diameter here from A to B, right? I know it's a diameter because it goes through the center. Well, if I know that diameter is perpendicular to this chord XY, so I know that's a 90-degree angle, then that tells me, okay, XY is being bisected, so these 2 segments are congruent to each other. It also tells me that this arc XB and arc YB are congruent to each other. Okay. Now, we could go into a proof of that if you're curious about why that is indeed true. The online textbook actually takes you through a proof, so you could jump on, you could look at that proof. But really, it has to do with similar, or not similar, congruent triangles, and our congruent triangle theorems. So you could look at that and you could kind of bring back those nice fond memories. Okay. Now, just like that last theorem, it goes both ways. This theorem goes both ways as well. Okay, so the perpendicular bisector of a chord, it goes through the center of a circle, so therefore it's a diameter. So what that tells us is, if, let's say, I'm going to get rid of this center. Let's say I didn't know that this was the center. Okay, if I have two chords in this case, okay, I have chord AB, chord XY. If they are perpendicular to each other and it bisects, AB bisects XY, so these two segments are congruent, well, then I know for a fact that AB is a diameter and it goes through the center C. Okay. Well, what is that useful for? That actually can help us if I have parts of a circle or just a portion, like an arc. Knowing that theorem, that can help us find what is the diameter, what is the radius, where is the center of the circle. So it's actually a useful tool if I just have parts of a circle. All right. And last theorem here. If two chords are equidistant from the center, then they are congruent to each other. And then vice versa. If the two chords are congruent to each other, then they're equidistant from the center. Okay, so looking at this picture, I apologize that it's a little blurry. All right. Remember, if I measure to a segment, I measure perpendicularly. So this says if LX and LY are congruent, so they're equidistant, well then I know FG and JH are congruent to each other as well. Okay. And again, it works both ways. So if I know FG and JH are congruent chords, then I know that those distances, so if I say this distance LX is 4, well, then I know LY is also 4. Okay. So just some chords theorems dealing with lengths of our segments here. So let's go ahead and apply those. Okay, so let's play around with our chords, determine the value of each variable. So if I look at this first picture, okay, well, what information does it tell us? It tells us that arc DE and arc FG are congruent. Okay, those have corresponding chords, DE and FG or GF. So I know that those chords are congruent to each other. Well, that means that I can set, remember, if they're congruent, I can automatically set those equal to each other. So 2x plus 6 equals 5x minus 9. If I want to solve, I'm going to subtract 2x from both sides. I'm going to add 9 to both sides, so 15. Divide by 3, so x is equal to 5. Okay. All right, let's look at the other picture. So this one, it gives us two congruent chords. And I want to know, okay, what are the arcs? Well, if the chords are congruent, remember the arcs are congruent. So y, right off the bat, I know is 75 degrees. Simple as that. Okay. All right. So now let's take a look at another example here. This deals with those middle two theorems. Okay, so it says the record shown has a diameter of 12 inches. So I know CD is a diameter. If FH is 10 inches, I want to know what is EG. So I'm just looking for what is, I'm looking for this part here, E to G. Okay. Well, how do I find that? Well, first off, I'm going to get rid of the actual picture. I'm just going to draw to represent as a circle. Now, it told us, if I look in the problem, the diameter is 12 inches. Okay, so from C to D, that's 12 inches. Well, that means our radius is going to be 6 inches. Okay, now we know all radii in the same circle are equal. So C to E is 6 inches, E to D is 6 inches. Well, that also means E to F here would also be 6 inches. Okay, now that's going to be key because if you look at this, I have a triangle here. So I want to know, that is the hypotenuse. I want to know that length. Okay. Well, let's think about what else does the problem tell us. It says FH is 10 inches. So FH is 10 inches. Well, if you think about back to that first or that second theorem, it says if a diameter is perpendicular to a chord, then I know that that chord is being bisected. Okay, well, if the whole thing is 10 inches, well, then I know if it's being bisected, this is 5 inches. Okay? So that's why we need to know that theorem. And so then I can look for EG. If I have a right triangle, I know two sides. What do we use? Hopefully you just said in your head Pythagorean theorem, a squared plus b squared equals c squared. Now the key here is that 6, that has to be rc squared. So I have, let's say, a squared plus 5 squared equals 6 squared. Okay? So when I solve this, I have a squared plus 25 equals 36. If I subtract that 25, I end up with 11. To solve for a, I take the square root of both sides. So a is equal to approximately, if I take the square root of 11, 3.32 inches. Okay, and I should really change this because it's approximate to our squigglies. Okay. All right, so I know that problem. It's a little involved. You have to know those theorems, though, in order to get these parts. Okay, without knowing those theorems, then we don't really have any starting point. All right, and last guy here. This one's fairly easy. Determine the measure of arc PQ. So in this picture, now this deals with our last theorem. It says if our chords are equidistant to each other, well, I know 8 and 8, those are the same distance. Okay, that tells me that these two chords, PQ, RS, those are congruent. So again, if they're congruent, I am allowed to just take those, set those equal to each other, and then I can solve. Okay, get my variables to the same side, so I subtract 2x, so I get 2x. I add 28, that gives me 32. Divide by 2, x is equal to 16. Okay, now remember it's asking us for the measure of arc PQ, so I need to take that, I need to plug that back in. So I have 2 times 16, and then plus 4. 2 times 16 will give me 32, plus 4 gives me 36 degrees. That is the measure of arc PQ. All right. So if you have any questions there, if any of this confused you, again, please hop on and make sure you clear it up with us. Okay. But if you've watched all 3 videos now, hopefully you can understand these 5 points. So we started with our central angles and then the arc measures. How are those related? Remember, they're equal to each other. Then we added our inscribed angles. Remember, the inscribed angle is half the measure of its intercepted arc. Okay. We also added in that inscribed quadrilateral. Okay. Remember the inscribed quadrilateral, the opposite angles in an inscribed quadrilateral are supplementary. Okay. So just a key point there. So just make sure you understand that. Okay. And then this video we looked at our chords and then how are all of those related. Okay. All right. So that takes care of our videos for this week. Again, if any of that confused you or you get stuck on the quick checks or you get stuck on the practice or the assessment, please reach out to us. Okay, we are here to help you out. We can't help you out unless you reach out to us, though. Okay. So your task now, again, we're going to suggest some practice that will be on the online textbook. I'll let you know those numbers. Hey, take care of that quick check on Schoology. Once you feel comfortable with that, take that assessment on Alex. Okay. Again, figure out a schedule that works out for you. Okay. Don't try to do this all at once. I know there's a lot. I know these videos are a little lengthy, but hopefully not too much. Space it out. Find a schedule to work through all your classes. I know there's a lot. Okay. If it ever feels a little too much for you, then let us know and we can try to scale some back. Okay. We want your feedback so we can figure out how to work with this stuff as well. This is new to us. Okay. I know it's new to you. We're all in this together. Let's work together. Let's figure this stuff out. Okay. Hopefully you have a good week. Again, we want to see your faces. Hop on to those office hours. We want to see you. It makes us happy to talk to you guys. Okay, if it's just for a chat, by all means, we love it. Cool. All right. Take care. Stay healthy. go outside, have some fun. The weather right now is pretty nice, so go enjoy it. Okay, keep your social distancing though. All right, we'll see you when we see you.